All right. Hello, everybody. Um, I'm Sam Ronsky. Today we are building a cloud game. This is day 3. We've been streaming for about 8 hours so far. Um, that's okay if you don't know where we are or what's going on. Please ask questions and we can answer them. But what we're doing is trying to build a game inside of Unity using C# and a bunch of other fun stuff that we know, and then trying to convert that into a cloud-based game. So connect it to the cloud and actually use that to make hopefully our game better and also give us a little bit more information about how everything works. So this is broken. I'm not entirely sure what's going on right now, but let's play this and we can just kind of walk through quickly what we've done so far. So the first thing that happened is we were kicked back to our main menu. Our main menu just gives us a way to log in. We're using PlayFab, which is a service that lets you add a bunch of different fun things that you might need inside of your game, whether that is logins or user statistics or event tracking or data and telemetry. There's lots of different things that can provide for you. And so what we're doing here is logging in. So we created a user yesterday, and we can also just create new users from inside of our game. There's lots of different ways to do this login. We've selected this one because that's just what we chose. Hello, welcome. So if we click login, we're going to log in and it's going to kick us over to the game. But I can also see I just logged in. There's now a user over in California where I just logged in, and if I scroll down, I can see a whole bunch of things just happened because I clicked log in and start game. We started our game, we collected some information about where the player was logging in from. We started a session, started tracking things like the focus of the game client. I switched to a browser, so we actually got an alert that the client focus has moved somewhere else. And we can also see things like player statistics. So we've added the ability to actually track the entire number of things. The Microsoft developer doesn't seem to be running. I think it's good. Is it not good? Let me double check that, because I'm not entirely sure. Yeah, you might be right. I don't know how to fix that. But thank you for calling that out. I'll think if I can think of some way to fix that. So I guess we'll continue on. What's happening right now is our players have statistics assigned to them. If we actually go and look at our player over here, we've created a total of 6 players. We've used 2 different login methods for this. When we were initially just kind of testing this out, we were using a predefined just ID. So if I go and look at this, these users do not have usernames or passwords associated with them. They're just associated with some custom ID. So if we know this custom ID, we can sign in as this user. That lets us create accounts that can kind of just not necessarily be authenticated with, but kind of be shared with any sort of custom ID. The other option that we had is using PlayFab IDs. So PlayFab IDs gives you a username, email, and then a password, and you can use that to kind of tweak things. So we search here again and find our recent logins. We can see this user right here. And this user does have a username. We disabled requiring emails just because I'm hoping we can make this accessible to all of you. And so we're not requiring personal information. And then there's no linked accounts anymore because it's just a username and password. If we want to manually go and change the password, we have access here. We can just go and set a new password. But everything else is tracked here. Players have a whole bunch of things. We started exploring these yesterday. We're going to dive a lot more into them today, because there's a few things that I kind of want to experiment with. Also realized we're probably not going to finish this today. There are certain things that I can't show on stream right now just for like Unity licensing and stuff. I can't, for example, tie that into GitHub on stream because I don't actually know how to do it, and I don't want to show something that could be wrong. So things like that we just probably aren't going to get to dive into. But here's our player. Players have things like statistics, and so here is all of the statistics for this player. We can create new ones as we want. We have games played, so we can track the number of games played by a player, the number of goals that they've allowed to be scored, and the number of goals that they've scored. So we can see this user's doing quite well. They've scored twice as many times as they have allowed goals to be scored, so that's a pretty good ratio. Things like that. What else? So we have all of those. None of these statistics are ever updated directly from a client. So our user doesn't have the ability to just go and override these statistics. They can't just upload anything. You might have like played maybe an indie game or something that had online high scores, and you might have seen somebody with like the maximum int value of a high score, which they probably didn't score themselves. They probably just used a REST API and just pushed that value up to wherever. The way we've done this somewhat helps prevent that, and we've done that by doing events. So instead of manually pulling down a number, incrementing it by 1, and then pushing up that number and saying use this, instead we've said when an event happens, like a goal is scored or a player starts the game, then increment statistics. And all of that is done through this automation tab inside of the rules. So we have 3 rules that kind of define how all of that works. We have our game started, and the other 2 are doing fairly similar things, but all this is doing is looking for an event that says game start. So this is just a string that we send from Unity up to our game. Unity detects or PlayFab rather, detects that event has happened, and then checks some conditions if we have those, and then we'll do whatever action it is. In this case, we're just incrementing statistics. We could do other things. For example, we can execute cloud scripts or Azure functions. So we can actually go out and just execute a REST endpoint, a web API, and do whatever that is. So you can do any custom implementation you want as part of that. You can also use this to send things like push and email notifications out to your users. If you require an email to sign up for your game, you have that email and you can use that to actually reach out to players and alert them for different things. You can also do things like granting currency to players. That is something that we'll potentially get to play with today. We are going to be diving into things that I have not actually used before. So we'll see how that goes, but you can grant things like virtual currency and items to your players so that they can actually use those in game. You can also handle things like deleting and banning players, which I have never used this for. So I'm not entirely sure how the best way to use that is. You can also attach extra actions, so you don't just need one thing. You can start attaching a whole series of actions to this and use that to kind of do a whole series of actions rather than just one. But yeah, that's that. If we look at these other ones, they should be a little bit more interesting because they have conditions. Because your events can have metadata attached to them as a dictionary, so a key value pair. And so we get a scoring team here, and we can either look at the north or the south team. Those are the 2 teams in our game. And this will help us detect who's scoring and for what team. And so you can actually use that to figure out if it's a goal scored for your team or against your team. And that's how these are working. And I think that's it. what else have we done? There's also player segments, so you can use this to track different players in your game. So there's a few that we get by default. Week 2 active players, lapsed players, and all players are all things that are created automatically for us when we create this. So we get all players, which is just all 6 of the player accounts we have. Lapsed players are players who have not played recently, so been inactive for a month or more. And then week 2 active players are the first login is less than 14 days ago, and the first login is greater than or equal to 7 days ago. So players who are active in their second week of playing the game. And this is just doing time comparisons to check that. And I think, yeah, that's mostly, I think, an example to kind of show that. And we created our own segment just for players who have actually played our game. You might have seen this in like Steam or other things where you get an achievement just for starting the game. That can actually be really useful because it can tell you people who didn't just download your game, but also at least started playing. They clicked that play game button on the main menu. And that isn't always 100%. And so in this case, we can actually automate that and get a actual metric here rather than rewarding an achievement or something like that. We can just say, has somebody played one game? We increment this when somebody starts a game. And so we can use this to detect how many players in our total players have actually played a game. In this case, it's just one. But we can sort of use that to kind of tweak things and understand a little bit more about what is happening in our game. Are people actually coming and playing? Or are they just kind of downloading it because they think it's interesting and then it just sits in that download folder for forever? Or is something preventing players from playing now? Like if this value starts changing and you're still getting new downloads, but you're no longer getting players who are playing the game, it might be an indication that something has changed. And maybe something that used to work is no longer working. So it can kind of help provide that information for you. There's a lot more information inside of this data explorer. That's loading. I tried to show this yesterday, but we had created this account like 2 hours into the stream. So some of this wasn't quite there. But now we can actually see, here's what happened yesterday. We can kind of get a bar chart of all the events that have happened over that entire period. So goals scored, player actions, entities logged in, so times people log in, player statistics changes, and client focus changes. So how many times a player comes in and out of our game. And all of those are going to be a little bit biased because I am demoing this, so I'm going in and out of my game constantly, which maybe isn't super helpful. But that's sort of what's happening. And we can even see, here's today. Here's what's happened so far today. So there's a whole bunch of information here. You can just go and play with this. We created this account like live in stream yesterday. And I haven't given it a credit card or anything. The free version of PlayFab is very generous, I think. So if you're interested in trying to play this out or play around with this, you can do that. You can just go and create an account, grab the SDK, and start playing around with it. So now what are we going to do? There's a few things that I would like to tinker with. I again have not actually tried any of these. I was reading about these last night, kind of planning what we were going to do today, and thought these would be fun. So that's what we're going to tinker with. Mostly what I would like to do is, one, we should fix this. Our AI is broken. But we should also take a look at our player config. Right now, all of the AI ships and things are pulling their ship telemetry, the data of how fast they can move, how fast they can turn, things like that. What I'm thinking we can do is move this up into the cloud. So that the ship speed and stuff can still have a local version, but we can actually keep a reference to this up in the cloud and actually be able to update it from the cloud. The really cool thing with that is I don't have to make every player have the same value. So if I want certain players to be able to move faster, or turn quicker, or however that works, we can adjust that. We also have information about like players scoring goals. So we can actually use that to tweak how accurate or how fun, I guess, our game is, because we can see our players scoring more goals if we make them move faster, make the ball bounce more, or make them turn faster. Those kind of things are things we can tweak. And then we can actually run experiments to see, does one value impact things more or less than the other value? And so that's hopefully what we can kind of dive into today. And then it will give us a way to kind of tinker with this. And then also hopefully set up an experiment so we can actually have different users that have different things. This is useful for a few different reasons. Talked for a while here. But the reason that these experiments are really useful is that we can actually set up like rollouts and things as well as part of this. So we can have a small percentage of users that receive this change initially, see if that experience is going in the direction that we expect it to, and then roll it out to larger audiences. This is maybe more useful if you have a existing audience that is more than like 10 people, or in my case, 1. But it can be a really fun way to kind of do that. It's something that we do in other cloud systems as well, where you have a canary rollout that is going to validate that your new release version actually works. And then if it does, you can roll everything else up and update it to that level as well. And if it doesn't, you can just roll it back and only impact a small percentage of users without everybody having an outage or something like that, because something didn't work. It also means if we want to tweak these values and try different things, I don't need to roll out new entire versions of my game. I don't need to go and rebuild the entire thing and ship a new version of Unity with all of my changes in it to all of my users that they have to download in order to see those changes. They'll get them like minutes or seconds later, which can be a really, really cool thing. So that's sort of, I think, where we're headed with this. Before we do any of that, I should figure out why this is broken. Because that seems important. Let's find out what's going on. Because I don't actually know. All right. We have a lot of things going on. Let's see here. Let's go and find our AI ship. Or not? Question mark. All right, let me quickly restart a few things just to see if that helps a little bit. And so the issue is we're getting a reference not set to an instance of an object error inside of our AI controller. And so I'm wondering, there's 2 ways that this could break. It could be an issue that we have, we're trying to detect a goal that doesn't exist, or it could be that we're trying to find the ball and the ball doesn't exist because we don't spawn that into our main scene. It shouldn't be checking for either of those in the editor though, so I'm not entirely sure. We did add gizmos to this AI so that we could more easily debug it. And so that could be part of the issue, is that we added gizmos and those gizmos are causing issues. But we're going to find out. That's that. Also, since this is the last day, if you're just joining us today and you have questions about any of the stuff you see on screen, please ask questions and we can go on detours to answer those and kind of explore for the next 3.5 hours whatever is interesting to you. So if there's certain things that you want to learn more about, or you see like a PlayFab feature and you think we should test that out, let's go for it. Only note there is we do not have time to test out multiplayer stuff because I don't know how to do multiplayer stuff. Yeah. So get target point. Why is this getting, oh, it's getting called there. Okay. So get target point, the way our AI works is it finds a target point and then calculates how to turn and apply thrust in order to get to that point. It's doing that using dot products in here. So we have some dot products to figure out how to adjust and turn and move our ship. But get target point won't work if ball state controller is null. So I think we can fix this by doing something like this. So inverting this and doing a the question mark dot inside of C#. What that is doing is actually asking, is the left-hand side null? So is ball state controller null? So inside of the editor, I think it would be, or rather outside of play mode, it would be. And then, so that'll be null. Then we'll look at our right-hand side if it isn't null and check that. So if this is now null, this should fail. That'll be false now. And so we'll end up down here. And I don't see any reason why that would fail. So hopefully it's all good. Cool. Great. Compiling scripts. Okay. So while that thinks, what else have I done? We haven't fixed the game arena yet. It's still primitive shapes. So for people who might not be familiar with game development, primitive shapes are your I don't know the best way to describe this. They're going to be cubes and spheres and capsules, shapes that are not like art stuff. They're just like default shapes. And so that's how we built our arena. We actually just took 3D shapes and just squished them. And so we have this. My goal with all of this, eventually what I'm hoping to do is to throw this into a GitHub project so that everybody can see it. That'll probably happen next week sometime. And then also attach CI to it so we can actually run through that. I'm going to do that off stream, and then we will have a stream later kind of talking about how all of that works. And then the idea is to end up releasing this as a WebGL game so that you can actually go to like a GitHub page and play this. I've never tried that before. So something that automatically builds something and then ships a GitHub page. I haven't tried that. I don't know if that actually works. So that's my goal. I don't know if that's actually going to happen though. If it doesn't, this will end up in some other place, but you'll still be able to access all the code from GitHub. And there will still be follow-ups talking about some of the other stuff. I did have some requests to do multiplayer as well. We're not doing that, at least right now, or for the foreseeable future. There's lots that we kind of need to think about in order to do that. And I wouldn't even know where to start. So that's something that I'm going to look for in the future, is trying to find somebody who knows how to do that. And then we can figure out how to apply that here. It'll probably take a lot of thought, I think. But that's something to look into. One of the reasons for that is that PlayFab has some multiplayer features inside of it, so that we can actually use that to create things like matchmaking servers. I just don't. I don't know what I'm doing. So Did this fix all of these issues? Let's clear these. It did not. Line 56 is still throwing errors because defended goal is null. Oops. All right, let's turn off caps lock and do if defended goal is not null. Then do that. Otherwise, we're going to go to 0, 0 and just circle around there. That might not be, that could cause some issues in the future. We could also stick something in here to automatically detect that we want to go back to this defended goal. If it's null, we could just go and look it up. Instead, I think I want to do this for now. And we'll see what happens. Yeah. So that was what was causing the issue is you can see right now we have these green lines. What's happening there is those are pointing directly to where these ships are trying to fly to. So if they have a target, it's going to point to that. It's going to try to fly to wherever that target is and get there. So if we start this, we should be able to see, and we no longer have these null pointer exceptions. We do have this one, but that's just from starting in the wrong place. So what's happening here, that PlayFab exception that we just got, that is caused by us starting in the game scene and then trying to log that we just started a game when we can't have started a game because we aren't logged in. So there we go. And now you can see all of these green lines kind of showing where the ship is trying to fly to. And then there was a smaller red one kind of in the direction that they're pointing. I think. That doesn't seem quite right. Yeah, I don't think that's working. Interesting. Let's fix that. What did I do? Okay, I'm not entirely sure what I was thinking when I wrote this. I didn't put a comment here, so I'm going to change this because it's not doing what I think it should do. And that is go forward. What I was hoping to do is have a ray going forward, and then we could see the forward ray line up with the target ray so that we knew things were in line with one another. That's just easier than relying on the geometry of whatever model we use, because as those models change, we don't always have the same reference point. So this gives us a reference point. Yeah, I think that's probably fine. Let's multiply this by 2. Or I don't think that's how you use this function. You do a distance, I believe. Nope. All right. We're just using array. And so rays are, I think, don't have a distance. So if we wanted them to be longer, I would switch this to a line. And then let's add a transform up. So this plus transform.up times 2. So this is just doubling the length of that vector, so it will be larger than the ship. We have increased the size of the ships over the duration of building this. So a unit length of 1 was just barely outside of them. This will make them more visible, so we can actually hopefully use them for actually debugging things. So that's the idea here. Yeah. Let's see. You can sign in this. And then we should see these change as the ball spawns. And then you can see these sort of red lines coming out of the ships so we can actually see where they're headed. And that seems a lot more useful than them just coming out of the screen at the camera. So there's that. Let's fix this other issue. So we continue to access our game ball after it's been destroyed. So we should probably have some way to update this and say that it should not exist anymore, because all of those null exceptions, the problem with that is it's actually going to cause lag in the game. Unity does not crash when you throw an exception, but what it will do is exit out of the method that it's currently in. And that can break things like our logic. So whatever we're trying to make our code do, it can also cause like stuttering, like you might have seen there. We're going to try to fix that and hopefully pull that out. So let's go and figure out the best way to do that. So when this is destroyed, let's go and find an object of our game ball controller. And let's just call this like notify ball destroyed. Something like that. All right. Using the wrong hotkeys. So notify ball destroy. That's just going to go out to our ball controller. Again, we're using this question mark. So if the left-hand side returns null, don't run the function on the right-hand side, because if it was null, we would get a null reference exception. So this is just a safety to prevent us from having to check that. So we can do this, and then our in play ball equals, oops, null. And I think we also have this. So update ball respawn. If the in play ball is null, we respawn our ball. I think we can move that here and get rid of this function. Like that. The only downside is we're still running a find. So every time that our ball is not existing, we're going to run a find object to try to find it. That's not great. We should probably do something to try to clean that up a little bit. But mostly my focus right now is just trying to clean things up a little bit, prevent us from getting some of these exceptions that we're currently seeing. And while we're at it, inside of onDestroy, this gets called when we stop the Unity editor as well. And so we don't necessarily want to try to create objects when we stop the Unity editor. We just want to do that when we destroy the ball inside of our game. So there is a scene dot, oh, I forget the function for this. I don't remember. There's a way to check if the scene is currently active. I have forgotten entirely how to do that though. Scene manager dot get active scene dot is loaded, I think. That will also probably include it being loaded because it's actually loaded. It's just not playing. I'll need to double check this. I'm going to leave myself a notice here. So there's a downside to to-dos like I'm doing here. This is actually something that I picked up somewhat recently, actually. If you just do a to-do and say only run this when in a active scene, not when the editor is shut down. The downside for writing a to-do like this is there's no way to track this. So there's no way for me to know who created this. You can use Git to kind of try to track it, but eventually this is going to end up getting refactored or something's going to happen that if this isn't already fixed, it's just going to move away. There's two ways you can kind of help that. You can either add like the issue number, so like number 123, and that would be like your GitHub issue number or whatever ticket tracker you use, or you can just say it's assigned to me, and put your username there, whatever your username is, and this makes it really clear of who you're writing this to. So if somebody else comes across this and is wondering if they should fix it or not, they know who to reach out to and ask questions because you put your name on it. It makes handling to-dos really easy, or not really easy, but it makes it less complicated. There's less potential for things to go wrong and for things to get crossed. A lot of times somebody's already working on something, and so this gives you a way to kind of know who that might be and to see if they're actually trying to like fix it, or if they created this and then forgot about it and went on vacation or something, and then it just never got picked back up. This can have one downside of the person leaving whatever project or company you might be working at. So sometimes the issue number can be more useful. It also means all of your issues are tracked in one place rather than having some to-dos and then some issues. So whatever works, but in this case, just having something. You can also add a date here so that it's slightly easier even then to know. That's less important with a Git system, but again, refactorings and things like that will change those your Git history and will make it a little bit harder if there's not an explicit date. But yeah, that's that. Anyway, let's add that there and run this and see if I've missed anything. So what we should do now is we should be updating our ball state correctly. I should fix tabbing. The UI doesn't tab between fields, and I should fix that. I have broken the game. Nice. Glad you were able to show up to all three, and welcome. Have you been able to use any of the stuff we've covered? We've covered lots. It's been a really fun week. We never spawned the ball. We never started our game. That's not good. Why not? Oh, that's why. Because so when we're doing this, I was relying on this update ball respawn to actually initiate starting to respawn the ball, and we never started that loop, so it never actually started. I need to do something to initialize this. So we could either put this in the start. That's probably the best place for it. So this is now going to actually set a ball respawn time, which means this will count down and actually spawn our ball, which wasn't happening because we changed the behavior of this so that the ball respawn timer was only set when we notified that the ball was destroyed, but it was never destroyed because it never existed. Oops. All right. So now All right. That's annoying me, so I'm going to fix it. Let's go and quickly do some UI stuff. I'm going to time box this at like 2 minutes. So we should be able to quickly navigate between UI elements. And we can automatically navigate between UI elements, but it isn't navigating. Is there a event system? First selected, send navigation events. Yes. Horizontal. Well, our first selected one, we want to be our username. So that's the username that's selected by default. So if I select this now, does this work? So you can see now there's a slight difference here. So now we're actually able to type directly into our username. But I can't navigate, and I don't know how to make that work. I thought it should have already done it. So I don't want to spend too much time on this just because we did that yesterday. But if I increase the spacing here, it might be a little bit easier to see what's happening. Inside of Unity automatically will figure out your navigation. So you can see there's actually arrows here already showing where things are headed, so forward and backwards, and sort of the relationship between UI elements. The trick is there's a button that I'm supposed to press and set up, and I don't know what it is. Hold on. Let's see if there's a component. I am not an expert at Unity's UI system. So let's go and... All right. The only thing for navigation is nav mesh stuff, which we do not need for this project. So we're just going to save this and move on. We will deal with that later, probably in some off-stream tinkering, but there's that. So we can now log in. And the lighting changed? Interesting. Okay. That wasn't what I expected to happen. But our lights in a different spot now. That's interesting. The game looks less interesting because of that. We lost all of our fancy lighting. But things work. We didn't get any errors, I don't think. Cool. So mostly cleaned up. I don't know why the lighting is doing that. It might just be some weird baking thing, but I don't think it should be. Anyway, what we're going to do now is work on this. So inside of our data for our PlayFab configuration for this, inside of content, I believe there's titled data. And we can use this to create key value pairs that we can then look up inside of our game and reference and hopefully use to tweak our game a little bit. So I haven't tried this before. So we're just going to see what happens and add a test of hello world. Cool. And then overrides are just a way to override the value of that. Okay, perfect. test. This is something that I need to take a look at. Title data is what we're looking at. So this is managing remote configuration. So what we were doing with statistics is managing individual players' statistics. So the number of games they've played, the number of goals they've scored, things like that. What we're doing here is not that. We're managing configuration across the entire title. A title is your game. And so what we can do with this is actually use it to configure parts of our game to do different things. I think what I'm going to do is use this test value as the name of our game. I think that'll be a fun way to just kind of test how all of this works. So we're going to load test and set it to this. So this spaceball title, we're going to swap that out and replace it with whatever's inside of that key. So let's go and figure that out. Let's do this remote configuration manager. And I might need to think a little bit about this of how I want this all to work, because we're potentially running into some async issues with how I want this to work. It might not become an issue on stream, but if you try to duplicate what I do, it could become an issue. So I'm trying to think about that a little bit. Let's go and create a new game object, and we'll just call this remote configuration. And we'll put that there. I'm going to need to rethink how I do my scenes in just a bit, but that's okay. For now, everything should be fine. We can talk about that when it becomes a problem. So what we want to do now is use our PlayFab API, or client API, to send a get title data. And this needs a get title data request. So var request equals a new get title data request with some data inside of this. And I think we just need the key, or a list of keys rather. So we're going to provide the new list of strings, and we were going to fetch test. Cool. So what I'm going to do actually, I think, is create, we're managing our remote configuration. What I'm going to do is create a public list of strings called keys to load ? Not like that. There we go. And what this is going to do is actually give us a way to configure inside of Unity the keys that we should be fetching. So if I do that, we now can provide that in the Unity editor, and then I'm just going to go and do a private dictionary. Strings and object probably is what we're going to get stuck with because of this. And so this is going to store all of that behind the scenes. So I read only dictionary, storing the same thing. Okay, let's talk a little bit about what this is all doing. So inside of the Unity inspector, we're going to see a keys to load array. We can just add strings to that, and then we're going to send that off to PlayFab and say, load these keys. What we're going to do is download all those keys, the data for those keys, and insert them into this dictionary. This dictionary is private, so we're just going to store it there. And that's just going to be a read-only thing that other objects can then look at and read the data from, so that they can use it to do everything else. We're going to load all of this before even landing on the main screen. That's why I'm saying we need to kind of rearrange our scenes a little bit. So all of this is going to happen in its own scene. And then this configuration manager is just going to persist over the entire game until you launch a new one. That also means we can potentially do like a fallback. So if you're offline, my goal is to launch this instead of a WebGL thing. But if you are offline, you will want some way to kind of handle offline configuration. And I'm not sure how that works. So that's something we'll probably need to consider as well. So get our title data with our request. And then we have on title data on title data error. Something like that. And then these are callbacks again. So these are gonna be things that we can respond with. And so if there's an error here, this is potentially where we'd want to load our fallback. So if we're offline, or if something else happens where we can no longer load our offline thing, we might want to have like a cached JSON blob or YAML document storing all of this so that you can actually reference it. That may not be a great option if you have like an online game where these values are kind of important. Because any client side thing is something that could be tweaked and changed, but we can think about that. That's not a big concern for this game because it's just single player. You're just hopefully playing it for fun. So on title data, we have our result and our error. And so the error, we're just going to log a error report like this. And then when we're getting our title data, what we can do is go and find the data. So we get back a set of data that we can then use for different things. So we're just going to copy that into our dictionary. Yeah. We're getting back strings, so I'm actually just going to use this as strings, and then clients can ask to parse it, I guess. I think that makes the most sense. So we'll load this, result that data, set that equal to our config. And then just for now, var key values in our config. So this should loop over our key value pairs inside of our dictionary. We can then use that to kind of log out what we got. So let's create an interpolated string and just do our key value dot key. And that has some key value dot value associated with it, just like that. And then that way, from our debug menu, we should be able to actually see what happens. Because the way I'm going to work on this is I'm actually going to take this remote configuration object, save it as a prefab so that I can tweak it from anywhere. And then we're going to just throw it into its own separate scene and work with it there, I think. Before I do that, let's test it here, I guess, and just see what happens. So we created test in our title data, so we should be able to go out and find that by providing a string here. And we need to be logged in to do that. Okay. I need to rethink how I want to do this. Oh, I suppose that makes sense. Because we're talking about doing experiments, and so your experiments are going to be assigned per user. So one user is going to get a specific set of data, and another user is going to get another set of data. That that makes less sense if you do all of that beforehand, if you've fetched all of your users, all the configuration data, and then logged in, because you don't know who you are until you've logged in. Okay. Let's go and throw this into a prefab quick. And I think we're going to need 2 scenes. So we'll delete remote configuration from this. Just to test things, I'm going to go back into our game and add the prefab here. Actually, let's not do that. Instead, let's go and create a new scene. Sorry, thinking about this on the fly. We're going to create 2 new scenes, and this one is just going to have the new prefab in it. So we've signed in, and then we're going to get sent to this screen. This screen is going to load our remote configuration and then forward us into our game's main menu. And then from the game's main menu, you could start a game. That's the idea. And then when you finish a game, like get 3 goals or a time limit elapses, we'll send you back to the main menu, and you won't go through the login flow again, because that's currently how this works. If you break out of signing in, you get sent back to the login flow, which is not what we want. Okay, I think that makes sense. And then we're just going to, on our remote configuration, we're going to do a login check and say login is required. This is a script we wrote that just checks if you're logged in. If you're not, it sends you back to the start of the game. So the first scene that is part of our game. Okay, let's attach this to the prefab instead. There we go. And then we can go and look at this. I now have duplicates of this because one of them wasn't attached to the prefab. You can save this scene. And we'll do remote configuration manager as our scene name. And then we're moving through our scenes using the scene count. So we can actually use that as a way to manage how users are moving through things. So inside of here is the scenes that we're using. So in this case, I have the main menu and then our 3v3 game. We're going to add this, and you'll see it has an ID of 2. I can move this up now. And so it now has the ID of 1. That's what we were using to actually move things about, which means that by doing it this way, I've basically eliminated the entire game from our game, because there's no way to get to scene number 2. That isn't a place we can actually navigate right now. We're going to need to update this so that we can get there. But right now, there's no way back. So what we can do, though, is run this. This is going to fail our login check, send us back to the main menu. There we go. I think, yeah. And then we can run this. So testing, and we can log in. And then there we go. So here is the new thing we downloaded. So we got test hello world inside of our collection. So we actually downloaded our thing. That's neat. Okay. So that's how we're going to get configuration. I just need to work out how all the scenes are going to actually play together so that this doesn't break, and so that you can actually play the game, because you can't anymore. This broke it. So, what's the best way to do that? let's create a main menu scene? Question mark. Also, I didn't add a camera to either of these scenes, so they are currently not super happy with me. Let me do that. There's a camera. Okay, perfect. We're just gonna leave that as it is and save this scene as our main menu. Okay. And so we need to go back into our build settings and do a final set of moving things around like that. Okay. So you'll log in, end up into the configuration manager. That's going to download everything or make sure that your data is there and available to you, and then send you to the main menu. At that point, everything it's just going to stay as it is. And to make that happen, I'm going to add another function here called on complete configuration. And this is just going to send you on to the next load scene 2. I don't know if hard coding these is a great idea. If we had lots of scenes, this would cause issues, but for now, I think it's fine. We're only intending to ever have 4. And if it does become an issue, then we can think about the best way to abstract that. But for now, after you've loaded everything, we can on complete configuration. Otherwise, right now, I think we're just going to leave it there. I'm going to leave a to-do for backup with local config if remote config fails. And then if that fails, then something is very wrong and we'll probably need to display like an error message or something back to the user so that they know it didn't work. But this should be fine for now, I think. And then the other thing that I'm going to do is attach this. What's it called? Don't destroy on load is what I'm remembering, but I'm probably getting that wrong. We'll be right back. Let's go and figure this out. Unity destroy on load. Don't destroy on load. Okay. Am I thinking this is a different thing than it is? I thought it used to do that. So just to talk a little bit about what I'm trying to do, I'm trying to prevent this object. Okay, it's a function. I thought it was an attribute. What we're trying to do is prevent this object from being destroyed as Unity loads the next scene. And what that's going to do is cause this remote configuration object to persist. This is why we're putting it in its own separate scene and then only loading that scene once. If we load the scene multiple times, we'll actually have multiple of these remote configurations and they'll start duplicating. By going from login to just loading this to our main menu, we prevent that because we can then inside of here turn on this don't destroy and load, and we want to not destroy this game object, not this. This is the script. This game object is the actual game object that it's attached to. And so that will allow it to persist. And so we'll create one, it will stay around. That should make things a little bit nicer. There might be better ways of doing this, like additive scene loading. But this seemed like a good option. So that's what I did. Yeah, there you go. And then we'll still move on to the next scene and then just maintain this. So inside of here, let's add a camera that we can use for like loading. Just for my own testing purposes, I'm going to make these different colors. I think something like that. And so we'll see like this gray screen when we're loading, and then a black screen in the main menu. This is just faster than doing a UI displaying loading. We can add that later, but for now, like we don't, our game doesn't work. So what I'm trying to do is get to that point as soon as possible, so we have something working, and then we can make it pretty, rather than the other way around of trying to make it look nice first, and then realizing we need to change all of that later. So yeah, there's all of that. Even though we have don't destroy on load, that only applies to the remote configuration object. Everything else is still going away. So we're not going to duplicate our camera. And then our main menu login is this. This should all still work. And then main menu, we're just going to add a quick canvas with a button on it. And for now, again, we're just trying to make this work. So play. There we go. Let's change the text so that it actually says play. There we go. And then we just need a really quick script to actually be able to load different scenes. So let's go and add that. Other. Interesting. All right, it's Unity's throwing errors, so we might need to restart it. I'm not entirely sure. It loses access to one of the files on my system, and that causes some errors in the future. Scene manager helper. Sure. That's as good a name as any I've given so far in this stream. So all this is going to do is provide a public function for us to go somewhere else. And that's it. Just some way for us to actually invoke this and then end up there. So once the key press gets recognized, we can write this function. It's only one line, so it should be pretty quick, and then our game should work again. But this time we'll actually have remote configuration loaded in, and so I should actually be able to see that as part of the game. We aren't consuming it yet, but the way I've constructed this, that remote configuration is going to be available when we load in our game, which means all of our tools that are currently preset can go and look there instead and try to load that. Okay, there we go. What on earth? It's thinking. So interesting. I may just restart Unity if that continues. We will see. And then I'm just going to remove all these functions. Public void play game question mark. and scene manager dot load scene 3. Cool. So scene 3 is our actual game. That's all configured from the build manager. And so this is now public. So what we're going to do is just attach this to our canvas and then reference that from our button so that the button can interact with this. So we attach it there, go to our play button and drag over, first create an on-click event, then drag over our canvas object and look for our scene manager and select the play game option. And now, hopefully, I need to add one other thing. Instead of here, we have a login checker that we've been adding to all of our scenes that are not the main one. All this is doing is just validating that you're logged in or not on every menu that you load, every scene that gets loaded. If you're not, it sends you back to do the login process. This makes this editor experience a little bit nicer because it means I don't need to load that main menu. We should just automatically get kicked back to login. Like that. So now we end up here and I can do the normal login flow. You can click login and we end up here. But we did flash through that gray screen, which is our, don't destroy and load, remote configuration, which is just kind of floating out there at a very far distance away. Might want to change that. But now we have a remote configuration. So if I play, or if I click play, we still have a remote configuration. It's still there with all of our stuff loaded in. So now we can do the fun bit. Now we actually get to go and figure out how we're going to tweak all of this. I'm going to start simple, I think, and just try to add one other thing. So we're going to get rid of this test. I don't think we need that. And we'll do ship speed. And the ship speed is currently, let's go here, look at our ships, 4,000. So let's set that to 4,000 and save it. Duplicate keys. Okay. Huh. I don't know exactly what that means, but okay. I guess one question I do have is, did I add a player data for that? Because so you can have title data, which is what we've been working with. You can also have player data. And player data will impact that player's specific stuff. So we have player data here. And so you can use this to store information about a player, not necessarily statistics or anything, but like actual player preference things that are more game specific. And I'm just using this to store raw values. So in this case, I'm storing like strings directly or numbers, but you don't have to do that. Like we could just store them as JSON instead, and then just parse that. So we could have one key storing everything with a relatively large like JSON blob defining how things work. And thinking about it, that makes a lot of sense, actually. Okay, so there's two ways that I was thinking of doing this. One, I could do ship speed, and I could do ship turn speed, and I could do ship drag, and ship angular drag, and ball drag, and like goal size. I could add all of these if I wanted to. and then just keep adding new keys. Or I could add ship, and then inside of here we could do a JSON thing of like speed 4,000, turning, just making things up quickly, 100, however we wanted that to work. We could do this instead and then parse this as JSON on our client side, and then we only have to manage like one key per blob of data that we're managing. That almost feels like it makes more sense. And as when it comes to actually saving this data, we can just write this to a file and then read that file back. And I think that makes sense. Let's do this one. Just looking at that, I think it makes a little bit more sense to try. So I'm going to delete test. We're going to add our ship characteristics. And this is going to be speed 4,000, turning equal to something. Let's open the correct thing. Negative 200, is that correct on both? So let's just do 200. I'm going to address the reason why that needed to be negative. We'll just fix that. And then drag. So drag is friction almost, but just how much is working to slow the object down over time. If there's no drag, an object with a force applied to it will just maintain that force and that velocity forever. That isn't always what we want. So sometimes we want to actually slow things down and make them go a little bit slower. This causes the player to have like natural stopping speed. So they'll slow down over time. And we set that to 5. And the angular drag is 3, I think. And so what I'm doing is just translating these options over to Unity. Let's also assign a mass to this. So mass is just influencing how much something weighs. When we're calculating forces, so objects hitting other objects, which is how this game works, mass is what's going to determine that. The important thing here is that changing this will actually impact how the player and the ball interact. So if they have the same weight, or the same mass rather, when the ball hits the player, it's going to apply a significantly higher force. So what I've done so far is reduce the mass of the ball, so that the player is less impacted. That prevents the ball from like turning the player around when they get hit, and allows the player to have like stronger shots because they can actually hit the ball and move it. But yeah, I think this makes sense. So the only downside with this is that if we want to experiment with this now, we're experimenting at the key level, I believe, not the value level. So if we wanted to change any one of these characteristics, we would end up having to provide all of them. I don't think that's a big deal though, because all of these are controlling how the ship controls. So they're all connected to one another. But I do think that's a reason why we wouldn't want to put everything in one key. At least for what I'm doing, I think that makes sense. I also want to kind of be clear here. I haven't used this. I'm learning this at the same time. So this isn't necessarily a recommendation on the way to do this. This is me kind of trying to use it and then learning how to use it. So we have our ship. Let's go and grab trying to think about what I want to actually do here. Grab our configuration. We'll get the ship data here. Does all of this make sense now? So I think there's a few things that I want to add as part of this. First, inside of our scripts, we're going to add an entire folder for configurations. And then I'm going to add a configuration data. So the ship configuration data is actually just going to be the data object that represents the JSON blob that we just wrote. So we can get rid of all of that. And we're going to create a bunch of properties here of float, speed, oh, ship name, that's interesting. What do we call this? Turning speed? Let's actually go and look at this. Oh, actually, I was seeing something about this. This. Perfect. So we can just paste a JSON object as a C# class in Visual Studio. So that's what I just did. So now we have this, and it figures out the types based off of everything. Everything in our configuration is all integers, but we actually want them to be floats, just because that matches the type inside of Unity. So we can move these all over into floating point numbers. And there is our configuration. And so now, how do I want to do this? Let's go and parse this, I think. Inside of here, we're going to get all of our configuration data on configuration complete. So inside of here, config ship. And I think we're going to manually start parsing this out. I'm also going to just remove that, I think. I think that's going to lead to potential errors. So instead, we're going to make this private and just specify it inside of here. I think that just will make things less fragile, because otherwise we could break our code. We could break all of our configuration just by changing something inside the inspector, which isn't what I want. So we'll do that. That's going to go and load the ship. And then this is going to have like raw configuration data. Let's also provide ship configuration data like this. And we'll do like a private setter. Does this work? And a public getter. And so we should be able to use this as a way to tweak how all of this should work. So what we're doing here is creating objects that are just going to store our parse data. This way we can parse it once, store all of that data, and reference it later without having to reparse it every time somebody requests, every time a new object requests it. That will just save us in the future having to do that. So on configuration, complete configuration, this is going to be parse configuration, and then we're going to load our scene. So private void parse configuration, something like that. And all this is going to do is take our ship configuration and set it equal to a JSON utility dot from JSON, and we're going to convert our config ship to a ship configuration data, like that. And this needs to be the type of that, like this. If you're wondering, this Unity has its own JSON options, so that's what we're using here. Okay, it does have a generic option. Perfect. We'll use that instead. It'll save us a bunch of casting. And there we go. So if I've done this correctly, we should have a ship. And it should get parsed out from our online configuration. So long way around getting to this, but now we can actually download our ship information, and the only thing that's really remaining, I think, is loading that. And we have, between our player and our AI, they both share the same way of doing that. They both share, oops, they both share their ship configuration. So we can actually apply this on both sides, and it should just work. You can see we loaded our ship configuration. So we have ship with a speed of 4,000, turning of 200, drag of 5, angular drag of 3, mass of 1. If I play this, nothing happens. We didn't use it, but we have it. And so I didn't start my debugger. That's why. Let's try that again with a debugger this time. Because what I'm looking to see here is that we actually are parsing things correctly, just to make sure that's all working before I try to actually consume it. So we have to enable debugging for this project. That's going to cause it to recompile, and then we can run this. It's thinking. Yeah. So what it has to do when you enable debugging inside of Unity is actually go and recompile your game with debugging symbols so that it actually knows how to figure out where it is in your code. So that's what's going on here. It's thinking still. There we go. All right, so test and testing. Log into our player. Here's our ship config. If we look at this, we have our ship, and I can step over this, and now our ship configuration is assigned nothing. That's what I was concerned about. Our parsing did not work. Let me quickly double check the docs on this. I also think, let me just make sure I'm not making myself do extra work. Okay, that's available to us. Let's use that. So I think instead of that, we can just use oops. JSON converter dot that, and that will convert it for us and use a library that I'm slightly more familiar with. I think we still may need to label our properties, but it also might detect it for us. So let's jump back to Unity, and then we can try this all again. And I should attach my debugger again. But all we're trying to do is just make sure that we're actually correctly parsing all of this. We'll cause a whole bunch of other issues if we aren't. So just by validating that that's actually working correctly, we can make sure it works. So there we go. Log in. And then we hit our breakpoint here. If I step over this now, we have our ship configuration, and now it actually has the correct information inside of it. So it has angular drag of 3, a drag of 5, a mass of 1, a speed of 4,000, and turning equal to 200. So that means we can use this now. So let's do that. While we've been talking, I've been thinking how to do this. And I think I want to do like a ship configuration applier. I don't entirely know if I spelled that right, but we'll try it. So the ship configuration applier is going to go and do exactly that. It's actually going to destroy itself at the end here. So destroy this destroys the game object, so, or not, it destroys the mono behavior, this script. It doesn't destroy the game object. And so we can use this to kind of clean up. If we have like a one-time script, this will run and then go away. So first we're going to get our configuration equals our find object of type remote configuration manager. Oops. There we go. And so at this point, that remote configuration manager has the data that it needs in order to work. So that's what that like gray screen that we flash up is. When that goes away, when we move on to the main menu of our game, we know that our configuration is actually loaded, that we have that available to us, because otherwise we would get an error. So we have that now, and we can also look at our rigid body equals get component of rigid body 2D. So that'll be our physics object, and we can also get our ship controller like that. And we're just going to start assigning everything to our ship. Just making sure. Yeah. So let's just start assigning these things. So rigid body dot drag equals our configuration dot ship dot drag. Rigid body dot angular drag equals the angular drag there. The ship controller has a speed, and that's going to be equal to that. It also has a turn speed, and so we're just going to assign that as well. We called it turning, so they don't quite map, but there we go. And then we had mass as well, so rigid body dot mass equals that. And so now we just downloaded all of this and assigned it to our object, and then the script will go away. But we can assign it to all of our components. We could use this for like downloading things like AI and things like that too. But I think this is neat. So what I'm going to do now is assign that modifier to it, to both of these. So once this loads, everything should be good. Also, this is going to break our AI because our ship controller currently is the wrong way around. You can see the turn speed is -200. So our AI is actually going to turn away from everywhere it's trying to get now. I don't entirely know what that's going to look like, but it's probably not going to actually work. So it'll be interesting. Okay, I don't actually know why it's stopped. um, okay. Got it. Okay. Oops. So I'm going to select both of our... Oh, I don't even need to. So the way we designed this, the AI ship is actually a derivative type of the player ship. So you can actually see there's scripts removed from the AI ship and added back in. We didn't need to do all of these, I don't think, but I did. So if we add this to the player ship though, so if we add our ship configuration applier, that should apply to the AI ship as well. We now have a ship configuration applier at the top of this, and we can use that to download everything. So we're in play mode. Whoops. Everything should be fine because we were adjusting prefabs. But if we try this again, hopefully we'll get thrown back here. We can sign in. Like this, do a login. We can use a user that actually exists. There we go. Download our remote configuration, click play, and everything flies backwards. Oh, that's awesome. So, oops, where? Oh, way down there. Okay. So because we have our turning backwards, everything is turning so that it's flying backwards at everything. That still works, surprisingly, but we downloaded all of the remote configuration. If we actually look at our player, all of this information came from that configuration applier. So it's all coming from PlayFab. It's not something that I defined inside of Unity. We're overriding that with the online version. We can tell because the turn speed is different. So that means if we want to change this, if we want to make everything fly upside down and not fix the bug, because fixing the bug means that we have to ship a code change. And maybe we don't want to do that because then everybody else has to go and download something. Let's just not. Let's go into our content here, find our title data, edit our ship data, make this -200. Heck, let's make it -500. And run this again. Now, no code changes are required because of this. I don't need to go in and modify the code. I don't need to ship a new version of the game. I can just change things, download this, click play, and we get the new thing, and now everything turns really fast. And they're all facing the correct direction. Because the angular drag is so low, things are behaving a little bit weird, but it works. And that's pretty neat. So now we can actually just start sending configuration and changing values to see what makes sense, what works. You can also start doing like experiments and assigning different values to different user groups. This could be something like providing increased rewards, like the first day a player comes back after being gone for a number of days. Whatever makes sense to your game. But we could also use it to like tweak our ship controls. We don't need to touch code at all here. This doesn't need to change. None of any of this needs to change, I don't think. The only thing that I probably should change is actually fix the bug, so that we don't need to use negative values in our turning speed. But other than that, we can just rely on remote configuration to control how our game works. I think that's neat. What we're going to try next is taking a look at running some experiments, which will allow us to tweak these settings for specific users. So that will mean that I can actually take a small part of users, maybe 5%, 10% of them, and apply different settings and see what happens. And then collect some data about how all of that's working to see if it was actually successful in whatever I was trying to accomplish. Maybe more goals scored or something like that. So where's our ship controller? Let's go and find it this way. There we go. So adding torque, we're just going to apply a negative value here. And I think that should fix moving around in our game. I should make it so that we can actually apply a positive value. So let's go and swap this back. We'll use like negative 200, something like that. Or sorry, 200. Do that and apply all of these. Cool. It's all configured for us. And then, yeah, let that figure itself out. And then we can actually come over here. This is less interesting since I only have one user that I'm using, but we can actually use this as a way to tinker with things. So if we go into experiments, we should be able to create a new experiment here and call this zoomies because we're going to make the ships go really fast. Ships very fast. And we can assign when we want it to start and stop, so we can actually kind of time box these things. Time zones are or time is all UTC. So that's going to be happening in a different time zone. Let's do. I can never remember if 12 a.m. is midnight at the start of the day or midnight at the end of the day. Anyway, we'll do 1 a.m. today, which should be now, I think, and just run it for a bit. We can also choose how we're going to target this experiment. We can run it for everybody, or we can just select certain users and just say, pick a specific number of users. We created segments at the yesterday. We can use those as a way to select who this applies to. So we don't have like level segments or anything like that we just haven't gotten that far. But we could use that to select different players. I'm just going to run it against everybody. And you can also introduce things like variants, which will change. This is sort of the classic A/B testing of one user gets this and the other user gets this. That's sort of what I've been leaning in or trying to talk about. Yeah. So let's do control variables, and I think I need to remember how this works. Let's see here. So there is PlayFab documentation out here. I've never used experiments before, so we're gonna kind of learn this together quickly by looking up this tutorials, publisher data. And well, here we have a search. Let's go and find experiments. Cool. So here's an entire section on experiments. And this is talking about how to actually effectively run them. There's lots of statistics here. If you're actually trying to figure out whether something actually makes sense, the sample size and things like that are actually going to matter. If you just sample like a very small percentage of your user base for a short period of time, it's going to be hard to actually understand what that means. So this is, I think, talking about that in more statistic speak. If you're interested in this, all of the different features of PlayFab are all documented out here, out on the PlayFab website. So I'll drop a link actually in chat so that people can grab that. Oops. If anybody's interested. There we go. And so what this is going to do is interesting. Give you a way to access all of this different information to figure out how to run your experiment. So let's go here to figure out how to run this. Scroll down. So what I'm interested in learning about is how we can actually run this and what the value is. So what the variants are doing. And so it looks like that's here. So variants are supported and defined by variables. Looks like we can have up to 10. And overrides. So the variables are attributes on variant groups to do different things. Okay, so what this is saying is that variants are going to target different parts of your audience. So we can actually go and look at this and oops, experiment. Let's go and check this out. We have run across all title players. We're going to target everybody. And then we have different variants. So what this is doing is including everybody in the experiment, but it's going to split those users into different groups. So I do not think users should move across those groups over time, but we'll end up here. What I'm curious about is this variable name testing and testing B. I'm curious if we have to do a little bit of extra work to set this up so that this will actually be supported, or if we can just use the configuration that we've already created as a way to work with this. So let's go and create this, and I think we can just click run now. Sure. Cannot be in the past. Okay. That makes sense. So let's set that for now. There we go. So this is just starting this experiment off immediately so that we're constantly running this. And then we can do that. Let's go and see what happens. Okay. It's thinking. There we go. So we end up with this. Now what I'm curious about, if I go and look at my configuration, when we download the configuration for our user, the question that I have is, do we need to do something extra to get that test data? Or is it going to come as part of this? So we called the value that we were using test, I believe. Making all ships fast. We can edit this and go and jump into this. So we're going to go and take a look at test as well. So I don't know why I didn't use an existing configuration we had, but there's test. So that doesn't go there, that goes down here. So what we should be able to see is whether we get something pulled down or not as a result of this. This might just fail, and then we'd have to figure out how to handle this. I'm not sure. We probably would need to go and look up some sort of thing. So let's do, whoa. Log in here, get our remote configuration. I didn't attach a debugger. That's not going to make this work. So let's go and attach to Unity and try this again. So we have our breakpoint set up. So we should be able to get something. Our thing also did not crash, which is good. So now that what we're really testing is whether this pulls down the test data or not, or if we need to do something else. My thinking is that it's going to override it, but we'll see. So we have our result, our data, and it just has the ship value. So the request for the test data isn't present, so we didn't get that. Okay, let me go and see if we can find some quick experiments for this. So we have all of our quick starts. If I jump over here to our quick start, let's see if we can get this information. Okay. I may need to do a little bit more digging than I thought. So usually before this, I'll at least look through and make sure I understand what we're trying to do. I may have misunderstood something when I was trying to dive into this, because I was thinking that was going to change our configuration, unless here. Let's go back to this, and I don't think I can change these because we already started this, so it's already running. So let's stop that experiment. Completed. Cool. Let's go and create a new one and try this again with slightly different settings. So this will be our ship experiment, and we're going to assign ship test. The names get slightly less interesting. And so we have this. We can add our variables here. And we're trying to interact with our, we're trying to interact with the ship variable by changing it to either empty or speed 1000. Just kind of making things up. We'll do speed 5000. And that's just arbitrary numbers, just testing this out to see how this works. So if we run this, we should hopefully get some quick information. All right. I'm sorry. So there's our ship test. We have two variants. Now if I run this, does it actually work? If this doesn't actually do anything, I may need to step back and rethink how this is going to work. Yeah. Okay. We'll come back to this. I'll try to learn more about this offline. Otherwise, we will be here for longer than I had planned. So we'll leave that as it is. But this is what we've built so far. Because everything should still work, even with that experiment just running in the background. We should just be able to stop this, actually. There we go. We have dynamic configuration for our player ships. So we can actually go in here and tweak this to do different things. So if we go into login, I can start tweaking how this works. This is the third page of what we've done. So what we've done is we've loaded our main menu. We've logged into PlayFab, loaded remote configuration, and then gotten to this play button. I can click this, and now we have players using the new remote configuration we used, with some slight hiccups, it looks like. But we can all play the game, everything works. But if I want to change how the game works without making any code changes, I can actually go into PlayFab, update the title data, and swap this over so we can make this. We're talking about making the ships go fast, so let's make the ships go fast. Something like this. So we can actually override that and make that different. Oh, did I need to create an override? That may be what I forgot. Oops. All right. We might need to quickly try those overrides, just so that I can make sure I know what's going on. So if I sign back in now, no code changes were made. We're relying entirely on remote configuration to manage this. So I can sign in, click play, and now everything is much faster and turns faster too. So we can actually like visibly move around a little bit better. It's maybe a bit harder to control, but that's one of the useful things of having this remote configuration is we can actually tweak that. We can figure out how this works without having to relaunch a new game every single time we want to update this. So the next time we launch this game, we're just going to get the new version, whatever that is. We'll just end up downloading that new version and using that instead. So let's go back to the experience thing. Override label, ship. Right. We're gonna jump over to the documentation and quickly look up how this works. And find so a override is a JSON key value pair and should be used to do delta change required in the key value pairs of the primary title data. Okay, so it looks like we can actually even delete keys from the configuration by just providing null inside of these overrides. So if I wanted to remove a value from certain users, I could just leave the value null. So here, like this is null. That would allow, in our case, I think that would just parse to 0 because we actually are kind of forcing the parsing. But if we wanted to handle that a little bit nicer, what we'd be able to do is actually use a way to shift this and hopefully be able to actually handle that a little bit more cleanly. That's neat. Okay. um Okay, it looks like there might be an example here. So we can create an override with labels. And then I think, okay, I think I'm understanding. Let's do this. We have our fast ships variant. So here's our ship. This is like the default behavior is to use this. What we can do is create an override. So if we want an override of like fast ships, I can add something for ship, and we're gonna do fast. We're already pretty fast, so we're gonna double the speed. What could go wrong? And then we're just going to save this. So we end up with our keys there. And so here's our fast ship. It's not used. If I run my game right now, that override isn't in effect, so it shouldn't be used. If I'm reading this correctly. So we can go and log in. We'll download everything, and our ship speed is still 5,000, not the 10,000 that I assigned it in the override. What we should be able to do is jump back here and create a new experiment called fast ships, and and then add an override here and say half of our players are going to get fast ships. So we're saying 50% of the audience is going to end up with fast ships. And PlayFab is going to automatically assign that for us. It's going to actually figure out how to figure out, or how to allocate half of your player base to one variant versus the other, because that's how we've configured it. And so if I run this, okay, whoops, losing my voice. Exclusion group names. What is this? Mutual exclusive experiments prevent interactions. We're overriding something that already exists in our game. In this case, we're overriding the default player base. We're using overrides for that. And so because of that, what this is doing is limiting this to a portion of our player base. So it's a mutually exclusive application of this experiment. So only some of the entire audience is even going to be included in this. Yeah. Okay. Let's run that. And what I'm curious to see is how we can actually figure out where players are ending up inside of all of these groups, because we now have theoretically 3 different ways like a player could be assigned. So once that starts, you can look at this, and then if I run this, I guess we'll see if we end up in the correct user base. What I don't know is the best way to set up like a testing group. I guess you would create like a segment for your developers and use that as a way to test things. If you were trying to test this in a production environment, you'd have some way of separating out those specific users. Because here we're still getting our old speed. So I don't know if there's a way to manually move a player in, but yeah. I think that's probably enough of playing with that. Let's go and finish up some of this, and then I think we can actually kind of start winding this project down. We've covered most of what I had hoped to cover over the past 3 days. Our goal was to build a game, add cloud components to it so that we can actually use different cloud resources to control our game. Mostly what we focused on is PlayFab stuff. And that's mostly because I think PlayFab is a really accessible way to get started with this. If you're new to using cloud services, especially from like a game setting, it provides that without you having to go and implement everything from scratch. And so you don't necessarily need to go and stand up your entire cloud infrastructure in order to start using this. That's why I thought this was really cool. That's sort of what we've done. So we're actually getting records of things like the goals that we've scored. So if we go here, we should even see things start to come into our player thing eventually. Oh, there's a goal. So as that player scored, if I go and look back at the play stream monitor, we can actually see all the results that are coming back. So we have team goal scored. So we can actually see that our player scored. Everything is working, and we're actually getting data. We actually send data about who scored, which is down here somewhere. Why can't I find it? I might be looking at the wrong thing. Because yeah. Oh, that's why. So what ended up happening is we scored. We're sending events up to our server. So in this case, we're saying we made a goal. Let the server know that we made a goal with this team and this current score. Provide that data to PlayFab so PlayFab can actually have specific rules defined for it. And what that's going to do is actually say increment the statistic on the player. So we're keeping track of the number of goals that any player in our game scores. And all of our players end up having these statistics associated with them. So if we search through all of our players and look at the current player that we've been playing with, we end up with players that have statistics. So these are tracking different values associated with the player. In this case, games played, which is the number of times we've actually ended up at that game playing screen, this screen, as a player. Then we also have team goals allowed, so the number of goals that you've allowed to get scored, and the goals that you've actually scored. So this player is still at about a 2-to-1 ratio. And all of this is handled on the server side. So instead of having the client work with this and manage how all of this is working, hello, welcome. Instead of having the client go and manage all of these values for you, what we're doing is actually having this managed on the server side. So the client just sends events. The client is just saying, this happened. How we respond to that is all based off of different server rules that we can manage online. And that prevents bad things from happening on the client. So clients can't just lie and say, I've scored 11,000 goals. Instead, they don't have access to this. They can just send single events. And so we noticed that we'd see like a big spike in this user's events suddenly if that ended up happening. Because there's no way for them to manually go in and change this online. All of that is defined in here. So inside of our automation, we have these rules. These rules are how all of this interacts. So we have team goals allowed, team goals scored, and games started. These are the different rules that we're actually using to actually figure out how all of this works. So when we receive one of those events from PlayFab, sending those events ends up looking like this. Let's go and find this. So in this case, we scored a goal. And we're also sending up a dictionary of additional data. So that's the metadata letting us know what team scored and what the current score is in the game. So we can actually use that to figure out how the game is going. And then we just write that up there. Right now, looks like we're not really handling errors. I should fix this. So let's go and implement these really quick. Complete. And this is just so that we don't end up throwing exceptions into the void and losing all references to them. This should prevent that from happening. So on goal scored complete, we're actually, I don't think, going to do anything there right now, but here we should log out an error so that if this happens for a user, we actually have a record of what's happening there. And this is just going to do the error message, generate error report. Oops. Cool. All right, so we're generating an error report there. That will give us a little bit of information about what actually went wrong, so we can fix it. Let's use a better name though, like error. And now we actually have our response, so we can actually write this event out, get a response, and then handle it however makes sense. So there's all of that. And then, yeah. Going back to what we were talking about, this is how all of those events are handled. Our entire code for sending these events is managed here. So we create a request based off of this and then send it up to the PlayFab API. PlayFab has SDKs for Unity and Unreal. And then all of that is backed up by a REST API. We were exploring this yesterday, where there's an entire group of all their APIs that you can just add to whatever API tool you prefer to use. So however you prefer to send your REST calls, you can use this. It comes with things like documentation, so we can actually browse through this. We were looking at player event requests. So if we go into client somewhere in here, there's a player event request, which I should just search for. Here we go. So we have our player event. These are all documented too, so you can just open up the documentation and see more about how this actually works. But here's how things like this actually are being called. And then that actually ends up going up to PlayFab and getting invoked. So the entire design of this is about the client processing and running into events and then sending those up to the cloud, and then the cloud doing things for us. And the cool thing with doing it that way, the reason why that's actually useful, instead of just adding a whole bunch of extra work, is that it means that your server, all of the processing stuff on the server, is not controlled by a client. So if you need to manage things like purchasing items, for example, if you have an item shop in your game, being able to actually purchase items directly from the client means that anybody that wants an item can just say, I own this now. And that might not be what you want. Might not be ideal. Whereas if it's managed entirely on the server side, it's managed through requests and responses instead. So events and then whatever is triggering that event. And the server can actually validate that request and give a response, either a yes or a no, depending on that request. Or in this case, it can just process it, perform an action, and then the client can use that new information for whatever it needs. In this case, we're just automatically incrementing player statistics for us. so we can just keep track of what's happening. Yeah. What else? We also added some custom data. Just slowly talking through this. There will be a GitHub repo for this if you're curious. And hopefully the actual game will be accessible too. But we added title data. PlayFab gives you options for managing data at different levels. So you can manage data at the title level, or you can manage it at the player level. So the player level would be data specific to a specific player. But in this case, we're actually working with data that is applied directly to this title. So the title is one game. And so what we can do with that is just provide a JSON blob of how we want this to work, which means that if I want to make our ships very heavy, and let's actually multiply all of this by lots. So that experiment is asking if we just want to override our experiment, where we can stop that. But experiments are how you would usually test if a change was a good idea. We're just in development mode, so we're just going to do this instead. So I just incremented a whole bunch of data about how our ships actually work in our game without any code changes. So what we're doing is we're just downloading a remote config file and using that to apply it to the ships. We can use that to make it possible for us to basically ship changes without having to ship changes. And so if we log in here, that gray screen that kind of flashes up is us loading that remote configuration. That's us pulling in that data. And now it's just loaded. We end up getting a log message here that our speed is now 50,000, which everything's really slow. We made things really heavy. So physics is maybe not great. I know it looks like it's slowed down, but it's not actually. Things are just slow. So you can do things like that and prevent this from happening in your game. So if you ship a game and it plays like this, if you want to change that, you can just go online and do that without all your players having to go and download a new thing. This is more significant for games just because it's usually a larger file size. It takes a long time to build. And if you're working with things like indie development, like that's typically where I end up working, what ends up happening is it's less easy to actually send changes out to people. It's not always as visible when a change is available or that you can use it. So yeah, there's that. So if we save this again, we'll get back to our normal zippy pirate ships, or not pirate ships, that's a different game. Spaceships, that's the word. And so we can actually fly around and do all the interactions that we expect. So eventually this will allow us to actually fly these ships around and play the game. And so I think that's mostly it. As far as what we're going to do next, I'm offline going to go and get this into Git. There's certain things that I don't quite know how to do yet that I can't do on stream. So mostly like license management. So I'm going to do that offline and then I'll share the solution later. But yeah, this is the game. Hopefully this was interesting. Hopefully the past 3 days has been interesting. Other than that, if anybody has any quick questions, we can answer them. Otherwise, I'm going to end the stream, I think, and I hope you all have a great new year. So that's this. Is there anything else I should say? I think that's mostly it. yeah. Did I miss any of the features we used? I think the only other somewhat interesting bit is inside of our title overview. One, we get a whole bunch of metrics about how all of this is happening. I didn't set any of this up off stream. This is just how it is. So we'll end up getting lots of information about how our game is getting played, how many people are logging in, things like that. We can also sign up for like email reports about how all this is happening, even user changes. We can see I'm no longer creating lots of users, so we've seen a user decrease over time. And there's lots of other information here as well if you want to manage that. But it gives you kind of a nice little overview of how things are going without you having to do that. My background with indie stuff means that I never had any of this information. So I only had a download number, and that doesn't even indicate that somebody actually even played the game, or if they are playing it, you don't know if they played it once or if they played it hundreds of times. And so this can help you kind of understand a little bit better about how that's all working. There's also the play stream monitor, which gives you sort of a live view of events happening across your user base. So we just have one player who just scored, so that's convenient. But we can actually see these events come in real time and actually understand a little bit more about how this is going. I believe these can be filtered. So if you have a more popular game, you can sample your data instead of just getting every single event, which is what these options are doing here, is just providing you ratios of a sample. So you'll look at a broader and broader picture rather than thousands of events if you have lots of users. So that's that. Other than that, thank you all for watching. Hopefully this was interesting. If you are curious and would like to catch this later, or maybe you missed a bit, leave a comment on one of the videos and I will try to respond. We'll probably be picking up this project as well and adding additional features over time. Yeah, the VOD should be available in a bit. So if you're looking for that, you should be able to catch it. This is the third day. So if you missed the first 2 days, the first day was mostly focused on Unity stuff. Looks like we scored again. Focused on Unity stuff and how we can actually use C# to build video games. So how that actually all comes together. The other thing we looked at is on day 2 is how we actually set up PlayFab. So that was like an introduction of like, how do we create a PlayFab account? How do we get all that connected? And what is the advantage of adding cloud services? And then today has just been kind of finishing all of that off and adding a little bit of extra stuff. We added remote configuration today. But yeah, that's it. So thanks everyone. And I hope you all have a good new year. So bye.